Hi there. Welcome to your May safety training. This month, we're going to focus on lockout, tagout, and electrical safety. I'm going to walk through this video with you, and some of the things that we're going to cover in this are going to be what is lockout, tagout, different types of energy, the lockout, tagout procedure, and then some electrical safety tips and common hazards that you may see around the property. So first off, lockout tagout is a safety procedure. It prevents team members from being unintentionally exposed to hazardous energy from equipment and machinery. Ultimately, what happens with lockout tagout is we have a piece of equipment that maybe is marked out of service, it's having issues, it needs to be repaired. So we would use a padlock type of device, which would secure an energy isolating device, and then a tagout device, which is like a tag just to kind of mark that it's out of service, which will warn team members not to use the equipment. So it's a two-part thing. We've got the lockout device, which just secures an energy isolating device so that the piece of equipment cannot work, and then a tag just showing that the equipment is locked out and tagged out and it's out of service. And if that is just too big of an idea to understand right now, think of it as putting a do not disturb sign on electricity, hanging it on a piece of equipment and saying, hey, I'm busy right now, don't bother me. Lockout tagout is critically important. We obviously want to know more about it. We want to avoid accidents and injuries, and continue to protect our team members and guests. In addition to that, with having that awareness of lockout tagout, we will avoid using equipment and machinery that's out of service so that we can prevent further damage to that equipment, as well as avoid personal injury by using broken equipment. We're going to talk about 6 types of energy: electrical, mechanical, chemical, hydraulic, pneumatic, and potential. Electrical energy will be your most common energy type. The sources of this, it'll be your typical plug-in with your wall outlet, the plug looking like the picture on the video right now. Also, with electrical power, that can include static electricity and electrical storage devices as well. Some injuries that can come from electrical energy, they're pretty serious. That can cause electric shocks, burns, electrocution, and explosions. So it's really serious stuff. It's really important that we pay attention and understand all of this. Mechanical energy is also known as kinetic energy. It's created by a mechanical movement. So this is what you're going to see with your power transmissions, your flywheels, belts, pulleys, anything like that. Contact with those moving parts can crush, fracture, cut, or amputate a body part. Again, absolutely critically important that we understand this and we're aware of this so we can prevent injuries. Chemical energy is energy produced by chemical reactions that could cause splashes and splatters of chemicals. So oftentimes chemical energy is going to need to be controlled in the pipes and other portions of equipment. And other dangers that come with chemical energy is going to be the gas or heat from chemical reactions, as well as hazardous chemical exposure, whether that is to property or us as individuals. So that can cause property damage and personal injury as well. Hydraulic energy is energy derived from motion and pressure of liquids. So this is going to be energy that's found in pistons, hydraulic brakes, piston motors, and hydraulic presses. Pneumatic energy is the product of stored pressure from gas or air in pneumatic lines and vessels. So pneumatic energy could be encountered in pressurized systems, compressors, so maybe like an air compressor, house air, air-powered tools, and then gases. Pressure must be relieved prior to servicing or maintenance, because if you don't, then obviously that causes a problem if there's energy in the pressure. The potential energy, that's going to be stored energy that could be hazardous if released. So examples of this would be gravity, springs, and thermal energy. So it has the potential to be hazardous. So we're going to look at our step-by-step lockout tagout process now. Got a little snapshot of it, but we're going to dive into each step and talk through that. So the first part of lockout tagout is to prepare for the shutdown. Really here, the idea is to just pause and take a step back and do your due diligence. Just understand what's going on. What is this piece of equipment? What do you need to do? So we want to notify the affected team members, identify the shutdown procedures for that piece of equipment and for the department. We want to identify energy sources, identify the energy isolation devices that you'll need, and then determine the quantity and type of lockout tagout devices that will be required for this piece of equipment. So this is all just kind of a research phase where you're figuring all of it out. You're not actually physically doing anything right now other than wrapping your head around what the next steps are. So the next step is the shutting down the equipment. So we want to just for the second step of the lockout tagout, just shut the equipment down using its normal start and stop method. A lot of times that's going to be a toggle switch or an on or off button. That's all we're wanting to do here is just turn the equipment off. Next, we want to isolate the energy sources. So this is where those energy types are going to come in handy. We are going to have to use energy isolating devices, but we have to use one that's appropriate for the energy source. So depending on the type of energy that the equipment is powered by, that's how you would select your energy isolating device for that piece of equipment. So this is going to prevent energy from reaching the equipment by disconnecting or isolating the power source. Then even if the equipment is turned on, it can't start up because the power source is not available. The fourth step is going to be to apply the locks and tags. So locks will be attached so that the device cannot be operated until the locks are removed. And that's going to lock that energy isolating device in place so that we're separating the energy and it will be unable to get power. And then the tags will indicate that the device and equipment may not be operated. Just something to keep in mind, the locks, tags, signs, and seals must all be securely attached, and the name of the authorized team member must also be included. Step 5 in lockout tagout will be to control the residual energy. So we want to release, restrain, or dissipate the energy and prevent the reaccumulation of energy while we isolate the space. We essentially just don't want more energy to be generated. And then step 6 is to verify the energy control methods. So with the lockout devices securely in place and all power turned off, this is where we would test it to make sure that everything is working, or in our case, not working as it should not be. So this is going to where we want to make sure that the switches, valves, and other mechanisms cannot be turned on. If they can be turned on, then we want to make sure that there's no power being generated. And then if it's an electrical energy source, we can actually use a meter to assure that there's no electrical energy present. So just making sure that the lockout was effective, that we've isolated the energy, all of that. The steps 1 through 6 have been successful. So just some quick electrical safety tips to cover. We want to make sure we never overload circuits. We want to keep cords away from water. One thing that I want to make sure we all understand is that extension cords are to be used for temporary needs, not permanent fixtures. So if you are at a property right now and you see extension cords as you're looking around and they're being used permanently to plug power sources in, make sure that you talk with your safety committee, with your GM, with your RDO, with your supervisor, whoever that is, so that we can find a solution long term. Not only can that be a fire hazard, a property and personal injury hazard, but if OSHA walks in, that's a hefty fine for something that is just it's an easy fix for us. We can find a solution. And then the last electrical safety tip is to report damaged equipment immediately. Some common electrical hazards that we might see, lightning being one of them. A lot of people may have jobs where they are indoors and outdoors. So it's just important to remember to seek shelter indoors. If you're working on a job outside, just be safe, use your common sense, and make sure, it's okay to pause if you're working a job that's outside. We get a storm and there's lightning. You can pause, go do something else, and then come back to that job later. Talk to your supervisor if you have any issues with that, or feel like it's absolutely mission critical, and you guys can talk through what that looks like. Wet conditions can also be a common hazard with electricity, so just avoid using electrical equipment in the rain or near water. Or if you have to use electrical equipment near water, maybe it's a water feature, maybe it is a pool, whatever that is, just make sure you pause for a second and kind of step back and look at the job, and make sure you are thinking through the entire process and get some help. Ask a supervisor or a peer if you need some, maybe a second set of eyes to look at it while you're working on something. And then again, common electrical hazards. We're saying this again because it's important. Those overloaded circuits. So we don't want to plug in too many devices. Again, that can be a major fire hazard. And one thing to note here, when it comes to overloaded circuits, power strips are to be used also as temporary fixtures. So we should not have power strips being used as permanent plugs for anything. Again, that's something that it's a fairly simple fix for us. And so if you can let your safety committee, your supervisor, your general manager, your RDO, whoever that is, let someone know and we can talk through that and find a solution. There's no point in us putting our teams at risk, putting our properties at risk, or risking OSHA walking in and giving us a hefty fine for something simple like that. So if you have questions about lockout, tagout, or electrical safety in general, whether it's just a broad question or something specific to your role, please ask your supervisors. Check with the general manager or RDO if your supervisor doesn't know or they're unavailable. And then, of course, I'll always be available at training@ohospitalitymanagement.com. That's also where you can submit your training rosters when you're completed at your properties. So thanks so much for watching. I appreciate you making safety a priority here at OHM, and we're just really, really grateful for you and all the things that you do here. Safety is one of those things that it's not necessarily the funnest thing to talk about, but we value you, and we want you to continue to go home better than you came to work. And because of that, it's just so important that we plant safety into our conversations daily, not just making it a monthly safety training topic. It's something that we talk about daily, and we just kind of integrate it into the rest of our job and conversations. So again, thanks for all you do. If you have any questions, feel free to reach out, and you all have a great day.